Record. All right, guys. Today we are doing the ambiguous case of the law of sines and the law of cosines. So two things. And all right, so we already did the law of sines. The law of sines says that in a triangle, right, A over sine A is equal to B over sine B is equal to C over sine C. All right, so the lowercase letters on top, those are the side lengths, right? And sine A, sine B, sine C, those are sine of the angles, right? Everyone can see my screen, right? Everything's good? Yes, no? All right. Okay, so find the remaining angles in this triangle below. It's not drawn to scale. So I want to find this angle and this angle. So if I call this triangle A, B, C, which angle do you think? Really gonna do this to me, Josh? All right, which angle do you think I should find first? Angle B or angle C? Which angle am I capable of finding first? All right, so type in B or C in chat if you don't have a mic. Let me know what you think. Think about this for a second. Which angle can we find first using the law of sines? C. Yes, we can find angle C. Thank you. Good. All right, so we can find angle C because, well, we have angle A, right, and the side opposite angle A. So I can set that up as 6 over sine of 30 degrees, right? So if we're looking for the angles, well, if I try angle B, I don't have the measurement of the side across of angle B. So I can find angle C first because we know that across from C is 10. So I can say this is equal to 10 over sine of C. Does it make sense to everyone? All right, so now we can cross multiply. We get 6 sine of C of angle C is equal to 10 times sine of 30. Everyone knows sine of 30 is equal to a half. And no, Emily, it doesn't matter if you change the fraction to sine A over A and sine C over C, that's the same thing. Right, you're gonna get the same thing when you cross multiply. You should get 6 sine C is equal to 10 times sine 30. Sine 30 is a half. 10 times a half is 5. And so sine of C is equal to 5 over 6. All right, now to find the measurement of angle C, I think in the last lesson I showed you guys this, we're gonna use inverse trig. So we have to take the inverse sine of both sides. Right, and I'm hoping you all know how to do this on your calculator. So I want to show you using my camera real quick what this looks like on the calculator. All right, so bam, we're going to do trig, the inverse sine of, and I already forgot the number. What was it? Inverse sine of 5/6, I think. Right, and up here, make sure you are in degree mode. All right. So make sure that says degree mode. If you're not in degree mode, you're going to hit the on button. You're going to go to settings, choice 5, and document settings, choice 2, right? And right over here, make sure that says degree. And then you go to make it default, hit OK. All right, so going back, you hit enter. And my calculator is weird. You have to hit control enter. You get 56.44 degrees approximately. So once we do this, we get C is approximately 56.44 degrees. All right, cool. So that's 56.44 degrees. And you know what? To keep it simple, I'm just going to round to the nearest whole degree, so 56 degrees. And that's 86 degrees. And then 180 minus 86, what is that? 180 minus 86, that's 94 degrees. Right? And that should sum to 180, and we're happy. All right. Cool. So that was law of sines. But what the heck is ambiguous case of law of sines? Well, let me tell you, this is ambiguous here. All right? Because this does not have to be 56 degrees. This could be something else. All right, do you guys remember on, well, let me show you first, because this is not drawn to scale. So another way I could have made or drawn this side length of 6 is I could have drawn it like this. And this is 6. Do you guys agree this is like another possible triangle that could be made with these side lengths of 30 degrees, 10, and 6? Right, that looks like another possible triangle, doesn't it? So if I did that, then, well, this here would be a isosceles triangle, right? So the two base angles are going to be congruent. So that could also be 56 degrees. And if that were 56 degrees, well, this here would be the complement, or not the complement, the supplement, and that would be 124 degrees. And if that were 124 degrees, well, then this angle up here, that would be 30 plus 124, that's 154, that would be 26 degrees. So there's two possibilities. We could have 30 degrees, 124 degrees, and 26 degrees, or it could have been like this, which was 30 degrees, 56 degrees, and I already forgot what the last number was. Hold on, let me just do it again, 94 degrees. There's two possibilities, and yes, I'm gonna post a video of this on YouTube, hopefully. All right, so there are two possibilities. Hence the name ambiguous case of the law of sines. And the reason this happens is because, well, if you do sine of 56 and sine of 124, they're going to equal the same thing. So I'm just using the rounded value here, just to keep it simple. And I'll show you that on the calculator. Let's take a look. Camera. Bam. Right, this is pretty hard for me to do, so if I make mistakes, I keep forgetting the angles. I can't see. All right, what was it? 56 and 124. So sine of 56, bam, and trig sine of 124. Bam, it's the same ratio, 0.829, 0.829. Right, so just know when you do this inverse trig function, right, when you do the inverse sine, it's always going to give you an angle between 0 and 90 degrees. Right, your answer will always be between 0 and 90 degrees. Answer will always be acute. They're going to give you an acute angle. But from our unit circle, if you remember our trig values, right? If you draw your reference triangles, if you remember, the value of sine was equal to the height in the unit circle. So sine could be equal to the same thing in the first quadrant or in the second quadrant. So there's actually two angle measures for any sine that has the same value in the first quadrant and the second quadrant. Right? For example, sine of 30 degrees is also equal to sine of 150 degrees. Right? Because let's say this is 30 degrees here. There we go. 150 degrees would be this, and that'd be 30 degrees. Right? We would have the same value for sine of 150 as sine of 30 degrees. And that's why we have two possibilities here, because of this situation. What will always be acute? The answer when you do inverse sine of something will always give you an acute value, right? So really, there's infinitely many values of c that gives us 5, 6. So sine of c is equal to 5 over 6, right? We were trying to solve that. there's actually infinitely many angles where it's equal to 5/6. But your calculator is always just going to give you the first one in the first quadrant, the acute angle. But like we see here, sine of 124 is also equal to 5/6, approximately at least. All right, so there's two possibilities here. And let me draw a picture. Reason this happens is if you think about this length BC, if you think about it fixed at point B, and it's like a hinge, right? If you drew a circle like this, right, that 6 could swing around and come to the other side. So there are 3 cases when you do law of sine. This case where you have 2 possible solutions, you can have 6 here and a 6 there, right? If you swing that length BC around point B like that. If this is too short though, let's say this were a length of like 2. If I said this was 2, then this triangle here would be impossible. You couldn't make a triangle with these dimensions where this was 30 degrees, this was 10, and that's 2. And let's take a look at why that is. So there's 3 scenarios. Probably should have gave you a lot more space here. I'm sorry. I didn't plan this out too well. I'm going to add a blank page. Add. How do I add a page? Oh, down here. Add page. All right, so I'm going to erase all of this and copy that. So in the original example, there were 2 possibilities. When doing or when using law of sines. All right, so what I'm going to do to figure out the 3 cases is I'm going to draw in the altitude or the height in this triangle, because it all depends on this height. All right, and I'm going to call that h. So to solve for h, right, I have that and that. So if I use this angle, 30 degrees, I have the opposite and the hypotenuse. So I'm going to be using sine, right? SOHCAHTOA. So I can say sine of 30 equals opposite h over hypotenuse 10, right? Now I can use these trig functions because I'm talking about a right triangle. And that's the only reason I can do sine 30 equals h over 10 here. All right, we know sine of 30 is a half. So a half times 10 when I cross multiply is 5. And this height here is equal to 5. All right, so do you guys see how this 6 here is bigger than 5? Well, when it's bigger than 5, you can also have a length of 6 here. So that's one case. But another case is, what if instead, let's say this length were 4? All right, could you guys imagine that? I'm going to draw out the triangle again. This here is a length of 5, 30 degrees. And if I said this was a length of 4, do you think it would be possible to make a triangle with a length of 4 there? The answer would be, it would be impossible, because if this here is a length of 5, then the 4 is not going to reach, right? I can swivel around this 4 as much as I want, but it's going to be too short to make another triangle. All right, does that make sense? Can I get a yes or a no in chat, please? All right, cool. So we have those 2 cases, and there's a third possible case. If this length here is more than 10, right? And I'm getting 10 from that side length, right? If this is more than 10, let's say it's 11. If I make this 11, for example, there's only one possible triangle because if I try swinging this around, well, the other 11 is going to be here, and then it's not the same triangle anymore. So there are 3 cases, and let's just write out in our notes those 3 different cases. I'm going to be using letters now. All right, so in general, if we have, I'm going to keep that as 30 degrees, why not? But if we have H, A, and B here, right, here's where it's going to get kind of weird. So case 1, that was when we had no possible triangle, right? There is no possible triangle when well, that was the case when B was too short, right? When B was like that long. So that is when B is less than the height, all right? So case 1, we will not have a possible triangle when that length B is less than this height that we drew. All right? Case 2, we will have 2 possible triangles, one here and one here. Well, that happens, that was the example we did in the very beginning, like this, right? 6 and 6. That's going to happen when this value here is in between the height and that length. So that happens when we're going to have 2 possible triangles when that value of B is in between the values of A and H. So it has to be greater than H and less than A. All right, and lastly, we have case 3. Case 3 is what I gave you every time the first day we did law of sines, right? And that is when B is longer than H. If B is longer than H, well, there's only one possible triangle, because if you try to draw it on the other side, if you try to swing it around, right, it's going to fall outside of the triangle now. So case 3 is we have one possible triangle, and that is when B is greater than A. All right, I know this is super a lot, all right, but ambiguous case of law of sines. So when we talk about the ambiguous case, we're most often going to be talking about this when we have 2 possible triangles. All right, cool? So let me put this back at the top of my notes. Bum, 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 bum. All right. So this was an example of case number 2, right? Because when we found the height, this was 5, and our B value here, 6, is in between 5 and 10. So that's why we had 2 possible values for our angles. All right, good? Any questions? Let me know if you have a question in chat about this, because that's half of our lesson. That's law of sines. All right, sup, Will?
Hello.
Hey. All right, good? All right, I'm gonna go on. So, law of sign problems, ambiguous case of law of sign problems. So a real estate agent has just taken a trade class at a local community college. She is considering purchasing a piece of property and is waiting for the surveyor's report before closing the deal. If the surveyor submits a drawing as in the figure below, explain why the agent will reject the sale. All right, this is the plan. What's wrong with this plan? Why is this real estate agent rejecting this plan? Well, let's just try finding the rest of the angles, just like in the warm-up. So I'm going to do law of sines. I'm going to do sine of 71 over 370, right? That over that. And I guess I'll find this angle here. So let me label this triangle ABC. So I'm going to do sine of angle C over 400. Oh yeah, and if you notice, by the way, I did it differently, right? It doesn't matter whether it's sine A over A or A over sine A, right? As long as you keep the proportions the same. So I did it this way this time. And let's see what we get. We're gonna get 400 sine of 71 equals sine of c times 370. Right, and normally I would, all right, and so I'm going to divide both sides by 370, divide by 370, divide by 370, and I'm going to get sine of c is equal to 400 sine of 71 divided by 370. Ah, very good, Tan. So let me show everyone else. 471, 370. All right. I'm actually going to type the values in here so I do not forget them as I do this problem. I have very bad memory. All right, camera. So we are doing trig. What was it? It was 400 times the sine of 71 divided by 370. And let's see what that's equal to. Nope, you gotta hit Control Enter. That's equal to 1.02218. 1.02218. Keep all the decimals you can. I'll show you on the calculator. I'm going to keep the exact value. But let's take the inverse sine of both sides now. All right, so I'm going to be doing next trig inverse sine of that value, and you can just copy and paste it. It'll plug in the exact value. So can anyone see what the problem is going to be? We did this once before. When we hit enter, bam, it's undefined. Because if you remember, the ratio of opposite to hypotenuse can never be more than 1. And what we're asking here is, we're saying what angle gives us a ratio of 1.022? We are saying the opposite side has to be longer than the hypotenuse, right? O over h is equal to 1.02. This is more than 1. That is impossible. That means this plan that the surveyor gave us is an impossible plan. It cannot be done. So the plan given is not possible. If I just try to find the angle measures, there is no angle measure for C that lets this be 400 feet, 370 feet, and lets that be 71 degrees. All right, so therefore, if you take a look, this should be a case 1. This should be a case where there's no possible triangle, and that happens when B is less than H. So let's try to find the length of H here. So that H is going to be this guy if you draw it. So let's find the length of H. So I'm going to do sine of 71 is equal to H over 400. H is going to equal 400 times sine of 71. Let me do that real quick. And that is equal to 378.2. Something, something, something. So as we can see, this height here has to be more than 370 feet, which is why there's no possible triangle. Cool? Does that make sense? Questions? All right. A slap. I don't know what that means. All right. Well, if you have no questions, I guess you can just remain silent. But if you have any questions, just type in chat, or you have a mic, guys. You can interrupt me. It's fine. All right. So over here, the surveyor admits to his mistake and revises his drawing so that the given angle is now 61 degrees. And this time, the real estate agent refuses to complete the deal until additional information is given. So I'm going to redraw the picture, but this time it's 61 degrees. Everything else is the same. This is still 400. This is still 370. And now the real estate agent is saying we need additional information. So let's find out why. Let me try it a little more like it was before. All right, so in this case, I'm going to do the same thing. I'm going to find the height again. And let's see what's going on here. So if I find the height in this diagram, it's going to be sine of 61 is equal to h over 400. Right? If I'm going too fast, let me know. Right? But if I do that, that's 400 times sine of 61. Enter. and I am getting a height of 349.8-ish. So if you'll notice, this 370 is in between the value of h and the value of a, right? So that means it's possible to swing this 370 around and have a triangle that looks like this. So this is the ambiguous case. There are two possible triangles that can be drawn here. So we need more information. There are two possible triangles that can be drawn. Does that make sense to everyone? So the additional information we need is like, what is this angle or what is that angle? We need another angle measurement. Need another angle. All right, cool. You guys with me? All right. So if you actually want to find angles, I'll do it super quick, but we can do sine of 61 over 370. Again, I'm doing law of sines. This over this is equal to that over that, or other way. So sine of, I guess I'll give it a different name this time. I'll call this angle x, x degrees. So sine of x over 400. All right, I'm going to do this all in one shot. So solving for x, x is going to equal trig sine of 61 times 400 divided by 370. All right, and I'm going to take the inverse sine of all of that. And what we get for x, it's pretty much exactly 71 degrees. All right, so the issue again is if this is 71 degrees, well, doing circle trig, here's the tricky part. 71 degrees looks like this. Right? So sine of what angle will also have the same thing? Well, if I draw this triangle, that angle is going to be, well, that's going to be how much? Well, this also needs to be 71. So 180 minus 71 is 109 degrees. So there's another answer here. Instead of 71 degrees, I can also say 109 degrees. And that should also be another possible answer for our guy here. Right? If you don't like doing this here with the reference triangles, you can also just draw it out. Right? Draw out the other possible leg here in the diagram. You can draw it out like this and say this could also be 71 degrees. So another triangle that could be made is this one. Right? This one on the left. The diagram can also look like this because it's not drawn to scale. And it could be a 61, 109, right? That's less than 180, so it's a possible triangle, and this could be 10 degrees. Or we can have the other possibility of 71 degrees. So ambiguous, you can have two possible triangles, right? That angle could be both 71 or 109 degrees. All right, good? So that is the first half of our lesson. That is law of sines, or the ambiguous case of law of sines, right? Now we got the law of cosines. All right. This video is probably going to be a little long, probably at least another 20 minutes. Sorry. So just to let you know. So a boat captain is traveling from point A to point B, 10 kilometers away. So a boat captain, he's going from A to B. A to B, and the distance from A to B, 10 kilometers. He heads 15 degrees off course to point B and travels for 5 kilometers before he realizes he is not on a direct path. So optimally, if you're on a ship, you want to travel straight across like that. But he's going 15 degrees off course, like so. So let's draw his actual path. He goes out like this. He's 15 degrees off course. And he travels in this manner for 5 kilometers. And let's say he's over there now. So he realizes he's on the wrong path. He changes route, and now he heads directly to point B. So from here, he now goes straight to point B. Zoom. How many extra kilometers did the boat travel compared to if a captain took a direct route regularly? So if he took a direct route, it would be 10 kilometers. And we want to figure out how much extra. So we need to figure out how long he traveled. So what's this plus this? So I am looking for, in this diagram, the length of, let's call this A, because it's opposite point A. All right, and I guess I can call this C. All right, so we have a triangle. All right, I know I drew my triangle to look isosceles, but it is definitely not isosceles, because if this were equal to 5, then 5 and 5 equal 10. You can't make a triangle with 5, 5, and 10, right? Our triangle inequality theorem. The sum of the 2 shorter legs has to be more than the third leg. So A is definitely not 5. So let's try to figure out what that length of A is. So do I have enough information for law of sines? Well, I have this and that pair, but I don't know either of the 2 angles. So I cannot set up another ratio to do law of sines. So law of sines is out. So this one's a little more complicated. What I'm going to do is draw down this altitude, and I'll call this H. All right, I'm going to do this because this makes right triangles. And now that I have right triangles, I can use my trig functions. I can use sine, I can use cosine, I can use tangent. So I'm going to label this first piece here X. And I'm going to call this Y, just so all the side lengths are labeled. And if I want to find the length of A, well, if I can find H and Y, then I can find A by Pythagorean theorem, right? Right triangle. So I'm going to try looking for H first. So I'm going to do a trig function that involves the length of H. So I have H, I don't want to use X, I don't want 2 variables, so I'm going to use the hypotenuse, 5. All right, so in this left triangle here, I'm going to be using my sine ratio. So I can say sine of 15 degrees is equal to opposite H over 5. So solving for that length of H, actually, you know what? Sine opposite over, all right. So H is equal to sine of 15 times 5. And I'm just going to leave it like that for now. So this here is equal to sine of 15 times 5. All right, if you don't like that, you can type it into your calculator, get the actual value. But I'm going to leave it like this. And now we need to find the length of Y. Well, looking at this triangle, I really don't have any angles. I don't have enough information. I only have one value in this triangle, which is this height. So I'm going to stick with this triangle still. And let's try to find the length of X, and let's see what that does for us. So if I'm looking for the length of X, I'm going to use cosine. I'm going to say cosine of 15 is adjacent, which is X, over the hypotenuse, which is 5. So I can say that the length of X, multiplying both sides by 5, is equal to 5 cosine of 15. And you know what? I'm going to move the 5 in front up here from before, just so it doesn't look too funny. All right. So this length of X here is 5 cosine of 15. Well, if I know the length of X and I know the length of AB, can we find the length of y? All right, think about what that would be. All right, that's going to be 10 minus the length of x, right? X plus y equals the length of 10. So we can say y equals 10 minus x. Nice, Erica. It's 10 minus 5 cosine of 15. All right, now we can use Pythagorean theorem and solve for the length of a. Right, because we know the length of h, we know the length of y, we can solve for the length of a. So solving for the length of a, we're going to say 5 sine of 15 in parentheses squared plus 10 minus 5 cosine of 15 in parentheses squared is equal to a squared. And if you want to do this in one step, you type all of that into your calculator with the square root, and you'd find the length of a. All right, cool? Does that make sense? I'm not actually going to finish this because I'll just post up a key of this at the end, but that is how we could find the length of a. So that was a lot of work. It's actually not too much work, but yeah, that's the way we can find a. But there is a much, much, much easier way to find the length of a, and that is if we use the law of cosines. All right? Just know that you will never be forced to use the law of cosines. Right? It's a little bit tricky of a law, but I want to show you where it comes from. But we were perfectly able to do this problem to find a using just law of sines. But again, there's another law called law of cosines. So I'm going to draw pretty much the same triangle as before. Right? And we started with this angle. Let's call it theta this time. Right? I'm going to be using letters for all of the values we had earlier. So again, let's try to find this length of a. And we were only given these lengths, B and C. All right? It's the same setup as before. So I'm going to break these down into their parts again. I'm going to call this piece a length of D, and this piece here a length of E. And let's call that H. So if you remember what we did last time, we found H, right? And we found a length of E. So let's do the same thing here, but in general, and let's see what happens. So first, probably should have written this out in the very beginning, but let's just write out SOHCAHTOA. So let's see. Looking for the length of H. So H over B is equal to sine theta. Hold on. So I'm going to use sine, opposite over hypotenuse, using angle theta. So sine of that angle theta is opposite H over hypotenuse B. And what we get is the height is equal to B times sine of theta. Is there a law of tan? No, there's no law of tangent. All right, so sine of theta is equal to that. If you remember, in the problem we did before, we did cosine of theta. Right, cosine of theta is going to be adjacent over hypotenuse, or D over B. And if we do this, we get cosine theta is equal to D over B. And solving for, what are we trying to solve for? We're trying to solve for D here, right? Because if we know D and C, we can find the length of E. So D is equal to B times the cosine of theta. And now if I want to find the length of E, well, E is C minus D. Right, D plus E is C, E is C minus D. Well, what was D? D was equal to B cosine theta. All right, I know it's a lot of letters. It's easy to get mixed up, but we're doing the same exact thing we did with the boat problem we did a second ago. Right, just with a bunch of letters. So E is equal to C minus B cosine theta. And now I can use Pythagorean theorem on that right triangle. So we know A squared is equal to H squared plus E squared. Is that right? Yes. All right, so the hypotenuse squared is equal to, what was the value of h that we found? H was b sine theta. So I'm going to take that, I'm going to plug it in. This is b sine theta squared plus, all right, what was E? E was c minus b cosine theta, that entire quantity. So c minus b cosine theta in parentheses squared. Ah, isn't this fun, guys? It's just like being back in the classroom. We're doing beautiful proofs. All right, let's square this. All right, we get a squared equals. So guys, I didn't teach you everything you need to know for this proof, but we have b times sine theta squared is b squared times sine of theta in parentheses squared. All right, plus, if we're squaring a binomial like this, right, we have to multiply it out. All right, from here it's all algebra. We're going to get c squared minus, what is that? Hold on, let me write it out twice. C minus b cosine theta times c minus b cosine theta. All right, so I get the c squared from c times c. Next, I'm going to have c times b minus cosine theta. And then I'm going to have two of them when I multiply this c with the b minus cosine theta. So I'm going to have minus 2b times c cosine theta. And then lastly, we have b cosine theta times b cosine theta. So that's going to be plus b squared times cosine of theta squared. Woo! Now let's clean this up. So, super messy right now. A lot of terms. But if you look at this and this, you'll notice that they both have a b squared in common. So let's factor out that b squared. I'm going to get a squared equals b squared times, in parentheses, sine theta squared plus cosine of theta squared. Right? Plus c squared minus 2b times cosine theta. Right, I'm just putting a little dot here so it doesn't look like two c's in a row, just to break it up. All right. Does anybody know what sine of theta squared plus cosine of theta squared is equal to? Wouldn't expect you guys to know, but does anyone know? Ah, Tan knows. Of course Tan would know. This is equal to 1. That's equal to 1. All right, so I haven't shown you guys that it's not in the geometry curriculum. Why is it equal to 1? Great question. So let's see why that's equal to 1. All right, so I'm going to go back to the unit circle. I'm going to show you a really quick proof or reasoning for why that's equal to 1. So if you remember, in the unit circle, a hypotenuse with a length of 1, right? This point here, this point was the same as cosine theta, comma sine theta, if this here is our angle theta. Right, and the reason for that, again, is if we do, for example, sine theta, that's going to equal opposite, let's call this y, over the hypotenuse, which is 1, right? And if I call this x, cosine theta is going to equal the adjacent, which is x, over 1. Right, so this point here, that's like x comma y. And we just showed that x was cosine theta and y was sine theta. So this point here is cosine theta sine theta. All right, so that y, that is equal to sine theta, this x, that's equal to cosine theta. So how are we getting cosine theta squared plus sine theta squared equals 1? The Pythagorean theorem, right? If I use the Pythagorean theorem now, do you guys see that we get this identity? We get x squared plus y squared equals hypotenuse squared, which is 1. Or we can say cosine of theta squared plus sine of theta in parentheses squared is equal to 1. All right. Does that explain it? That's equal to 1. I just used Pythagorean theorem on this unit circle here. I didn't also have to make this 1. I could have made it any length. This will still be a true identity. It's just more work, but easiest to see here. All right. You don't really need to know that, but we go much more into this in Algebra 2. But that's your quick reasoning of why this is equal to 1. So b squared times 1, all of this is equal to 1, is just b squared. So we can say a squared equals b squared plus c squared minus 2bc cosine theta. And that there, my friends, is the law of cosines. And this does look like the Pythagorean theorem. And it pretty much is the Pythagorean theorem. It's just modified, so it works for any triangle, and it does not need to be a right triangle. So that is our law of cosines. Bam. All right, so what do A, B, and C represent? Well, that theta, that was angle A, because that's across from A. So I'm going to replace this theta with A. And there we go. That's our law of cosines. So I'm just going to do one example of this, and that's going to be it. So if you go back to the boat captain problem, we could solve for A using this equation in one step, rather than having to do all of that. All right. So this works for any side, for any angle in a triangle. If you don't have enough information to do law of sines, you can probably do law of cosines. So this angle A, it's 2BC, right? BC are two sides. This angle A here, this will always be the included angle between B and C, between two sides of it. So for example, if we go back to this example, right, that's B and that's C, 5 and 10. So that angle, angle A, that's always going to be in between those two sides. Right? And then it's the same B, it's the same C. This A here, right, this will always be across from this angle. This is the side across from the angle that you're using in the formula. So it's the side across from the included angle. All right, so of course, in like a random triangle, it doesn't have to be labeled A, B, and C. So don't take the letters to be law, right? You have to think about what it actually represents. So let's take a look at this question here. And let's see. So we got a triangular playground that has those three lengths. So with just the lengths, we can find all of the angle measures using trig. So I'm going to draw out a triangle playground. Maybe something that looks, I don't know, like this. The longest side was 595, so I'll start with that. Which one looks longer? This one looks like it could be 401. This looks like it could be 475. All right, so we got a playground with these lengths. And it asks us to find all of the angles. All right, which angle do you want to find? The left one, the right one, or the top one? It doesn't matter. All right, someone type left one. All right. Let's find this angle. So if we're looking for this angle, well, let's see, A squared equals B squared plus C squared minus 2BC cosine of angle A. So I'm going to be calling this the included angle. That's the angle we're looking for. So I don't want to use the same letter, so I'm going to call this x degrees. So we know the cosine of x, right, minus, so BC are the two sides that make the angle A. So that's going to be 401 and 595. So it doesn't matter which one you make B and which one you make C, but B and C are going to be 401 and 595. So let me write those in. So I'm going to say 495 squared plus 501 squared minus 2 times 495 times 501 times cosine of x, right? And A goes with that A, of course, right? Angle A is going to have side length A across from angle A. So in this case, I used x. So that's going to be 475. And there we go. So this part, it looks like the Pythagorean theorem. It doesn't matter which side is the hypotenuse, though. There is no hypotenuse. It's not a right triangle, right? And the fact that it's not a right triangle, we have to add this extra factor into account for it. So it's just like a super fancy Pythagorean theorem. Did I mess it up? Oh, it's 401, not 501. Who wrote that? All right, thank you, Emily. 401 squared, not 501. Is that right? Yes, 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 yes. All right, thank you. And we solve for cosine x now. So yeah, it's a lot of algebra, but I'm going to subtract 495 squared, subtract 401 squared, and divide by all of this. So if you want to see that in action, well, I don't know the best way to do this. Oh, you know what? I'm going to screencast Desmos. I'll do it on Desmos so I can actually see my notes. Hold on. Let me open up Desmos, and I'll show you how I would type this in the calculator. Also, I wrote 495 instead of 595. Ay, ay, ay. All right, I fixed it. Let me share a different screen, though. New share. Let me share Desmos. All right, guys, can you guys see my Desmos screen now? Yes or no? All right, cool. So I'm going to be doing 595 squared plus 401. And that's not typing out. Uh-oh, that's not good. There we go. 595 squared plus 401 squared. Hopefully you guys already did this in your calculator. All right, we got 475 squared, and we're going to be subtracting that quantity. So let me copy and paste that. That's negative 289201. And then next, if you're just doing the algebra, we're going to be taking this number, and we're going to be dividing it by negative 2 times 595 times 101. And so that is 2.406. And I feel like I made a mistake. So let me double check this. 475 squared minus 595 squared. All right, minus 401 squared. Good. Get that number. We're going to divide it by negative 2 times. Oh, that's not 101. That's 401. That's fine. 401. All right, so we get 0.60605, 0.60605, and a whole bunch of zeros. All right, and let me go back here. How do I share? New share. Go back to my iPad. Kind of go to mirroring. Ooh, I can mirror my TV onto you guys too. I'll show you my TV. Anyway, bam, we're back here. So doing all this calculation, you get 0.60605, 0, 0, 0, 0, 0, 0, a whole bunch of zeros. is equal to cosine of x. Right, we're going to do the inverse cosine of both sides. So if I take the inverse cosine of 0.60605, that's going to equal x, and that is equal to, I should have finished this on Desmos, but functions, inverse cosine, let me copy and paste that number, bam. Also, I need to be in degree mode, and that is about 52 point, did tell us to round to what? To the nearest tenth of a degree, so that's around 52.7 degrees. You still see Desmos? Oh, I got resume share, sorry. So I wrote we got 0.600605 equals cosine x. Am I recording? Okay, good, I'm still recording. Equals that, take the inverse cosine of both sides, and we get 52.7 degrees. All right, we have one angle, 52. Well, let me leave it as x so we know where that came from. That's 52.7 degrees. Oh man, do you guys want to do law of cosines 2 more times to get those missing sides? Probably not, because it's a lot of calculations, law of cosines, I know. So what could we use instead? We could do law of cosine, law of sines, right? You can do this over this, right? Sine of 52.7 over 475 is equal to sine of either one of these angles over its opposite side, right? And that will let you find another angle, and then we know angles in a triangle add up to 180. So I think you guys can easily finish the problem from there, all right? And I'm not gonna finish it because this video is already going way too long, but that's gonna be it. I'll put this question here on the homework. I think that's the last one, all right? And all right, so that's gonna be it for today. All right, I don't wanna make this too long. It's already a pretty long video. So we good? Any questions?